Welcome back for the continuation of the online classes on the topics matrices. We first recap our class what we have done in the previous class. If you recall, we have defined matrices, we have defined order of the matrices, we have defined elements and entities, we have defined types of matrices, we have defined equality of matrices. I told you about the addition and subtraction of matrices, and categorically I told you that multiplication is not as we do multiplication in our simple algebra. So multiplication of matrix we have to understand very carefully. This is the one of the important thing in the chapter, concept in the chapter. Now multiplication of matrix, if you go for multiplication of matrix, now this multiplication of matrix, there will be two things. Number one, we can multiply by a scalar number. It can be multiplied by a scalar number, or it may be the given matrix we wish to multiply by another matrix. So these are the two things which we have to understand. One is we can multiply a matrix by a scalar number, and the second is we want to multiply a matrix with another matrix. So in the case if you wish to multiply by a scalar number, this is very easy for us. If A is a matrix 1, 2, 3, 4, 5, 6, this is a matrix 2 rows and 3 columns 2 by 3, and if you want to find a matrix 4A, that means this matrix to be multiplied by 4. So as simple as that, each element of the matrix to be multiplied by the scalar number, that is 4. So if you multiply, it is 4, 8, 12, 16, 20 and 24. The order will remains the same, only the element is multiplied by 4 because we want to multiply the matrix by 4. This is one of the important information we have to set in mind. In the same way, when we want to take out something common from the matrix, so if you want to take something common from the matrix, so it should present in all the elements. It should present in all elements. Then only we can take out common, otherwise not, which is not in the case of determinant. This way also we differentiate matrix and determinant. In the case of matrix, the common element should be there, and that number to be present in all the elements, then we can take it out as a common, otherwise we cannot take it out as a common. Now the next is we want to multiply a matrix by another matrix. So if you wish to multiply a matrix by another matrix, in that case, so the topic is, it is again multiplication, but we are multiplying multiplication of a matrix by another matrix. So here the most important condition is that a matrix can only be multiplied by another matrix if the number of columns of the first matrix is equal to number of rows of second matrix. This is the important condition, and then two matrices can be multiplied. So the number of columns of the first matrix is equal to number of rows of the second matrix, otherwise we cannot multiply two matrices. For example, suppose if A is a matrix of Aij and having order m by n, and B is a matrix B of jk, it is n by p, B of jk n by p. Then if you want to multiply, you can see the number of columns is n, number of rows is n, so these n are same, so they are equal. This is equal, n equal to n, number of columns is equal to number of rows. So when we multiply, we get another matrix C, okay, C which is equal to small c, j and j neglected, so ik, it is ik, and we get the order m by p, we get the order m by p. So this is the order of multiplication of matrices. It is not so easy, we have to multiply in a very careful way, because for doing the sum, this multiplication must be clear for all of you. One important information is here that it might happen in the matrix multiplication AB and BA, but AB and BA are not equal. In our simple algebra, A into B is equal to B into A, but in our matrix multiplication, A into B may not be equal to B into A, because if it will not satisfy the criteria for multiplication, so it might happen A into B is defined but B into A is not defined. We can check that by example also, and based on this also we have many sums in our exercises. Okay, so let us do one question so that we can define this A into B and B into A. Okay. So take one sum, and at the same time, so that you will learn how to multiply. So if suppose we are taking a sum, if matrix A 2, 1, 3, 2, 1, 3, minus 1, 4, 0, and matrix B 1, 2, minus 1, 4, 0, 5. So these are the two matrices are given. Okay, and we have to find AB and BA. And the question is find AB and B. So if you see carefully, if you wish to do this sum, everyone please give focus, because multiplication of matrices are not so easy. So you can see having 2 rows, 3 columns, so this is 2 by 3 matrix, 3 rows and 2 columns, so 3 by 2 matrix. So here, if you do the sum, here A is a matrix 2, 1, 3, minus 1, 4, 0, 2 by 3, and B is a matrix 1, 2, minus 1, 4, 0, 5, 3 by 2. So you can see number of columns in A is equal to number of rows in B. So A into B is what? Defined. A into B is defined. A into B is defined. Okay. Now the thing is how we multiply this. So if you multiply A into B, so this is 2, 1, 3, minus 1, 4, 0, 2 by 3 matrix, into B is matrix 1, 2, minus 1, 4, 0, 5. This is 3 by 2 matrix. So these two are defined, maintaining equal. So the final matrix which will come will be a 2 by 2 matrix. The final matrix is a 2 by 2 matrix. Now the question is how to multiply. The simple rule is that first you multiply first row with first column, first row with second column. First start with the first row and multiply all the columns of the second matrix. You can go column wise also, it depends on you. Whether you multiply rows wise, column wise, that is immaterial for us. So first we are doing, we are multiplying first row, first column. So that means it will come like that. It will come like that. We multiply first row into first column. First row into first column. Then first row into second column. We get the second elements of the resultant matrix. Then second row into first column. We get the third elements. Then second row into second column. Because we get finally a 2 by 2 matrix, that is clear for us. 2 by 2 matrix, that means we get 4 elements. So what are the 4 elements? So this first row is multiplied with first column, then first row is multiplied with second column, then second row is multiplied with first column, and then second row is multiplied with second column. Okay, so first row, first column, first row, second column, second row, first column, second row, second column. In between them, positive sign will be there. So please multiply carefully. So you will observe 2 into 1, 2, minus 1 plus 0. 2 minus 1 plus 0. Okay, 2 into 1 plus 1 into minus 1. So minus 1, 3 into 0. So first row, first column done. Now first row, second column. First row, second column. 2 into 2, 4. 1 into 4, 4. 3 into 5, 15. I told you in between positive sign is there. That is always. Then second row, first column. Minus 1 into 1, minus 1. Plus minus minus, minus 4. 0 into 0, 0. Then minus 1 into 2, minus 2. 4, 4 is 16. 0 into 5, 0. So you get a matrix of 2 by 2. So finally you are getting 2 minus 1, 1, minus 5, 8, 23, 14. So this is a 2 by 2 matrix. This is the answer for A into B. So A into B is defined and A into B is a 2 by 2 matrix. Now if you find B into A, now for B into A, we have to check what is the number of columns for B into A. Number of columns in B. Number of columns in B. Number of columns in B. How many columns in B? 2. And how many rows in A? 2. So number of columns in B is equal to number of rows in A. So here BA is also defined. So here BA is also defined. But it may not be true always. Here BA is also defined, but that may not be the case always. It might happen A into B is defined. You are getting A into B, but you cannot calculate B into A. That means B into A is undefined. I have taken the example here, keeping in mind, if we calculate the values of A into B, we get a final matrix 2 by 2. At the same time, we calculate BA, which also we get a 2 by 2 matrix, which also we get a 2 by 2 matrix, 3 by 3 matrix. And we can understand AB is 2 by 2, but BA is becoming a 3 by 3 matrix, which proves A into B is not equal to B into A. So here B into A in the same way if you follow. So B into A, so B is your 1, 2, minus 1, 4, 0, 5. Okay, this is our 3 by 2 matrix. 3 by 2, this is multiplied with A. A means 2, 1, 3, minus 1, 4, 0, and this is our 2 by 3 matrix. And if you multiply in the same way, so you can see 2 and 2 are matching equal, number of columns equal to number of rows. So finally we get a matrix which will be of 3 by 3. There will be 3 rows and 3 columns. So if you multiply in the same way, okay, so you will get here, you will see that you will get here 0, 9, 3, okay, then minus 6, 15, minus 3, okay, and then minus 5, 20 and 0. Finally, you'll get this. So you'll observe that A into B is not equal to B into A. So here A into B is not equal to B into A. So I told you that B into A and A into B is not correct in the case of matrix multiplication, which is correct in the case of algebra. Okay. Now we have to study the properties of multiplication of matrices. The next topic is, this way you can do many questions. If you see the book, everyone in the NCERT, please, you will see the textbook and you will observe there are many questions, okay, in our exercise 3.2. You can do exercise 3.2. So now we have to discuss the properties of multiplication. Properties of multiplication of matrices. The topic is properties of multiplication of matrices. So properties of multiplication of matrices, more or less we know the properties, but still I need to discuss once. So there are very simple properties of multiplication of matrices. Okay, And the properties is like that. Number one is the associative law. So if we have three matrices, associative law. So if we have three matrices A and B and C, so A into BC is equal to AB into C. This is associative law. A into BC is equal to AB into C. Okay. Then we have distributive property or distributive law. Distributive law. In the case of distributive law, in the same way, A into B plus C is A into B plus A into C. A into B plus C is equal to A into B plus A into C. Or it can go like that. This way also, it can be like this. Okay, A plus B, first we are adding two matrices, multiplying by C, so AC plus BC. So this is called distributive law, associative law. These all are very simple and easy properties, you know, from our simple algebra also. The most important which I want to tell you, that is the existence of multiplicative identity. Existence of, this is one of the important information, existence of multiplicative identity. Because using this concept only we do elementary operations for the matrices. In the next class, whenever we have the classes, so we can discuss that topic, how to find the elementary inverse of a matrix using elementary operations. So that time we need this concept. So existence of multiplicative identity. So multiplicative identity, if there is any square matrices, for any square matrix A, so for any square matrix, for any square matrix A, there exists a matrix, okay, there exists a matrix of the same order, there exists a matrix of the same order, such that A into I, if you multiply I by, because identity, I for the identity matrix, we have already discussed I2, I3 means 2 by 2, 3 by 3, which are called identity or the unit matrix. So there exists a matrix of the same order, such that if you multiply the matrix by that identity matrix A into I, or you multiply the matrix by identity, we get the matrix itself. So A into I is equal to I into A, which is equal to the matrix itself. So this is one of the important properties. Okay, so this is one of the important properties which we use for elementary operations for getting the inverse of a matrix. So A into I is equal to I into A is equal to A. The next topic which we discuss, and the topic is transpose of a matrix. Transpose of a matrix, and after this we do 1 to sham, and then you can follow the NCERT textbook. You can complete using this concept exercise 3.2 and 3.3. First class, whatever we have discussed, exercise 3.1 was done. Today I told you about the multiplication of a matrices by another matrix, by a scalar matrix. We have discussed some properties of multiplication of matrices. Now we are discussing transpose of a matrix. Transpose of a matrix. So transpose of a matrix. Now transpose of a matrix. So if we have any matrix, okay, if we have any matrix of A is Aij, M by N is a matrix. So if we interchange the rows and column, the matrix obtained by the simple definition of transpose is the matrix obtained by interchanging rows into columns, or maybe vice versa. Rows into columns or vice versa is called the transpose of the matrix, and it is denoted by a dash or A, T for transpose. Any notations we can follow. So we can follow any notations. So the matrix obtained by interchanging rows into columns or vice versa is called transpose of the matrix. Mathematically we denote by A dash or AT. Using transposition of a matrix, it will be help us in calculating the inverse of the matrix and all by using the formula. Okay. So now we have to learn some properties of transpose of the matrix. Properties of transpose of a matrix. Properties of transpose of a matrix. So properties of transpose of a matrix, number one property is that if you transpose a matrix, again you transpose, you get the matrix itself. That means theoretically it is the transpose of the transpose matrix is the matrix itself. The transpose of the matrix is the matrix itself. Number two, we have if we are adding two matrices or maybe subtracting two matrices, if you transpose, it is nothing but equal to the separately A dash plus minus B dash. Okay. Number three, we have A into B. If you multiply two matrices, if you transpose, so it is not like A dash B dash, it will be like B dash into A dash. This is called law of reversal. This is called law of reversal. Law of reversal. So if you transpose any matrix and again you transpose the matrix, you are going to get the matrix itself. Okay. If you are adding two matrices and then you are transposing, if you are adding and transposing, you are going to get the transposed matrix as a sum or as a difference, as the case may be. Okay. If you multiply two matrices and transpose, so you will see that the order is reversed, means A into B is changed into B into A, that means B dash into A dash. This is called law of reversal. And the fourth is that if A is a matrix, if you multiply by any scalar quantity and if you transpose, so K is a scalar quantity will be as it is and only A dash. So these are the four important properties we have on transposition of matrix. For example, one example you please try to understand. If A is a matrix, suppose 1, 2, 3, 4, 5, 6, and this is a 2 by 3 matrix. There are 2 rows and 3 columns. And simple question is find the transpose of this matrix. So it is simply nothing but A dash is equal to. So first row will turn into first column. First row is turning into first column. Second row will turn into second column. So this is the transpose matrix. So having 3 rows and 2 columns. This was 2 rows, 3 columns. It is becoming 3 rows and 2 columns. Okay. Now again if you transpose this is transpose matrix. Again if you are transposing, so you can observe first row will turn into first column. Second row will turn into second column. Third row will turn into third column. That means having 2 rows and 3 columns, and you can observe this is nothing but the original matrix itself. This is nothing but the original matrix itself. So that means if you are transposing a matrix 2 times, the matrix will come back again. The matrix will be coming back again. Okay. Now one more sum I want to do, and after that your homework is exercise 3.2 and 3.3. Whatever I told you, if you have understood that much, I hope you can easily do the sum. So before we wind up, at least we do one sum, and the sum is very easy, simple on addition and subtractions. So question is find x and y if find x and y. This is your NCERT sum, very easy sum, it is given in the NCERT book. Okay. If x plus y is given 7, 0, 2, 5, any values we can take, and one simple question, x minus y is equal to 1, 2, 3, 4. Suppose the question is find x and y, x plus y is given and x minus y is given. So we can do in different ways. One method is that as we have done the solution of linear equations in our class 10 standard, this is equation number 1, this is equation number 2, and then if you are adding these two equations, so plus y minus y cancel, you are getting 2x equal to something, it means x equal to that to be divided by 2. Or otherwise, simple what we are doing, once we are adding this, adding this 2, so it will be x plus y, okay, plus x minus y is equal to, this is 7, 0, 2, 5, and then plus, it is 1, 2, 3, 4. So you can see plus y minus y cancels. So it is coming 2x equal to 8. Corresponding element to be added 0 plus 2, 2 plus 3, 5, 5 plus 4, 9. This is your 2x. We want x. So that means each element to be divided by 2. Each element to be divided by 2. So that means it is coming 4, 5 by 2, 1, 9 by 2. So these are the values of x. 2x is this. So x is what? Half of this. Half of this means each element to be divided. Already I told you in the case of matrix, if you are multiplying, this element to be multiplied. If you are dividing, each element to be divided. And once if you are subtracting these two equations, you can see x plus y minus x minus y is equal to 7, 0, 2, 5 minus 1, 2, 3, 4. So minus x plus x cancels, plus y minus plus y, 2y. So 2y is equal to 7 minus 1, 6, 0 minus 2, minus 2, 2 minus 3, minus 1, 5 minus 4, 1. So y is equal to again half of this, means 3 minus half, minus 1 and half. So this is the answer for y. So keeping this much information in mind, you can go for 3.2 exercise as well as 3.3 exercise. The questions are based on addition, subtraction, solving of equations, based on some question on transpositions, and many sums based on multiplication of matrices. Stay healthy, stay safe, and maintain social distancing if in the case of emergency you are leaving your home. Thank you. All the best.